Recording. Okay. So powers of I. So by definition, um, I is the square root of -1. So we just called the square root of -1 I, so we could solve problems like it. Really, what they were using this was to solve cubics, but we'll see they come up a lot in quadratics as well. Um, I squared is by definition -1. I'll try and give a little bit more intuition, but I mean, other than just saying it's by definition, if anyone wants to come up with a better way to explain why is I squared equal to -1, if you want to come up with a better explanation, I'll give you extra credit if you put something small to like a slide or two in Google Slides, and if you want to share, if you don't mind sharing like if you have a better explanation. But I squared is -1. I thought a little bit about it. I'll give a better explanation maybe on Thursday. But right now, I'm just going to say by definition, I squared is -1. If you want to come up with a kind of better way to think about it, I'll open that up for extra credit if anyone wants to try and answer that question. Um, and I don't know if there is really a much better answer, to be honest, but I have a little bit, maybe more of an intuitive answer. I've been thinking about it. All right, so I to the first power is I, or the square root of -1. I squared, like we said, by definition is -1. So based on these other rules we have, and honestly, I'm just gonna just keep this as I, because usually we don't write like the square root of -1, we just keep it as an I. So I to the third, though, if we break up this power, if you remember your exponent rules, this would really be I squared times I. So since we know I squared is -1, that would really be -1 times I, or this would be -I. I to the fourth, similarly, if you kind of break it down, oops, would be I squared times I squared. Because remember, when you multiply exponents, you add the powers. So that would be I to the fourth. So we're not changing it. But based on our definition of I squared, this is really -1 times -1. So -1 times -1 would just be +1. So I'm gonna kind of show you in a second, but these, like when you have I up to a power, you're gonna get one of these four answers. You're either gonna get I, -1, -I, or +1. Like these are the only four answers we'll be able to get. And I'm gonna kind of show you here quickly. And then I'll kind of try and maybe show you kind of a more visual representation if it helps you see it maybe better in your head. Um, how I like to I think the easiest way to break this down is how many I squareds can you pull out of your power? So I to the fifth, you could pull out two I squareds and you'd have an I left over. Like, so that would be five I's really. Because when you pull out these groups of two based on that definition, let me see if I can squeeze this in without it looking awful. Like this would really be -1 times -1 times I, or that would just be I. Same idea with I to the sixth. That would be I squared times I squared times I squared. So that would be -1 times -1 times -1, or that would be -1. I to the seventh, that would be the same thing, almost just an extra I. So it would be like we just saw, it would be -1, but then we'd have an I left over, so it'd be -I. Oops. And then I to the eighth would really be I squared four times. Or that would be -1 times -1 times -1 times -1, or +1, because every two negatives turns positive, basically. So if it helps you, I try to kind of draw it as like a circle. If it helps you kind of maybe visualize it in your head a little bit more, is this it? Put it down here. What you're going to notice is it's kind of like seasons, or it's kind of like a clock. So I up to the first power is going to, oops, didn't mean to erase that. I up to the first power is going to be I up to the fifth power is going to be I. Every four numbers, it repeats. Like it takes every 4 i's, it comes back to the same point it started. So like if it helps, you could kind of even draw this picture and just kind of count around the clock if your power is not that high. So for example, I to the 5th, start here. So 1, 2, 3, 4, 5. I'd be back to where I started. But you start with 1, you don't start with 0. Like, so for example, I to the 7th, start here, 1, 2, can I highlight here? Like 1, 2, 3, 4, 5, 6, 7, I'd be down here. Like if that kind of makes sense how to count around the clock. You could kind of use this visual representation to kind of help you think about it. Or let me show you another way to think. Like, so I don't know if this makes any sense. Like you could kind of count around this clock. You always start here at the top at like this would be your first power, and like you want to go clockwise. Like, but you could kind of count around the clock if that's kind of like, if you want to just kind of like tap, like if you draw it on a paper, I kind of tap with my finger, just kind of keep track with it. So let me go back to our notes though. Another way you could think about it, if you don't want to, like, if you're not as visual or you just don't feel like looking at it that way. So we want to figure out what I to the 15th would be. Really what you want to think about is how many I squareds could you pull out of 15? So, or really how many times does 2 go into 15 without like a remainder? Let's see in the chat. Oops. 7. So I have a few people in the chat. Yep, tell me 7. So really we would have, like, you could write that like I squared. And I'm not going to write it out 7 times. We'll just put it up to the 7th power. So that would be 14 of my i's. So I'd still have an I left over. So really remember, I squared is -1. This is really -1 up to the 7th power times I. Or you'd have to ask yourself, -1 times itself 7 times, is that going to be +1 or -1? One easy tip. Wait, was someone saying? I didn't mean to talk over you.
-1.
-1. One easy way to do that is if it's odd, -1 up to an odd power is going to be -1. -1 up to an even power is going to be positive. Every even exponent, like anytime you square a number, it turns positive, but any even exponent turns a number positive. An odd power keeps the sign. So if it's negative, it stays negative. So this would be -1 I, or just, we would probably just write that as -I. Or if you did the clock, you would see it would end up back at this 3rd spot, like here, like if you wanted to count around the clock. But some of these powers are going to get kind of big. So that visual representation does kind of have its flaw, like especially if you have giant powers. But I'll be honest with you, when we're dealing with most of our like problems in this class, I mean, other than like I'm just having you do this to see if you can, we're really not going to get that high powers. Usually like the highest you'll see is maybe I to the 4th. But you might see this more like in a future class if you're doing more with like complex numbers. So how about you guys try number 14? So think about how many I squareds you can pull out, and then take that I squared up to that power. So like, which would really be -1 up to that power. So try 14, see if you can figure out how many I squareds can you pull out of 62. So like, well, how many can you pull out? All right, so if you don't mind me saying, Labria, you told me you could pull out 31, because 31 times 2 would be 62. So that would actually be all of our i's we would pull out. So we're not going to have like an I on the outside in this one. So that would really be -1 up to the 31st power. So since that's odd, that's going to be -1. Like, or you could even put that in your calculator, but I mean, if it's an odd power, it's going to keep the sign. If it's even, it's going to turn positive. And I hope you guys could see my screen. I had the window slide it over. I don't know if that affects you or not. Okay, so we're going to look at some expressions with I and kind of just see how these work. This is kind of a preview of what we'll be looking on Thursday. We're going to look at complex numbers, which is basically an imaginary number with a real part, but we'll kind of define that. then, but we just want to see, can we simplify these expressions? But we're going to use those powers we saw. So when you're multiplying like imaginary numbers, you just multiply the coefficients, just almost treat it like a variable. So you would multiply 4 times 7, that would be 28. And then I times I would be I squared. But remember, an I squared is really -1 by definition. So this would equal -28. How I think of it is anytime anytime I'm simplifying an expression, anytime I have an I squared, I switch the sign. And if I have a higher power, I just keep switching the sign. So if I had I to the 4th, I would switch my sign twice or it would stay the same. So this one, same idea, multiply like 16, you would multiply your coefficients. So -4 times 2 would be -8, times -9 would be +72. I times I would be I to the 3rd. So like this is how I think of it in my head. Well, an I squared would basically turn into a -1. So that would switch my sign. So that would use 2 of my i's and I would have 1 I left over. So let me write that a little bit neater. But so the answer for this one would be -72 I. Basically, you want to pull out those I squareds because an I squared is -1. It basically just switches your sign, if that makes sense. So how about you guys, don't worry about 18, but see if you can do 17. Ooh, actually 17, 2i to the 3rd power. We have to simplify that first. So you basically got to cube each part. So that would be 8i, because 2 to the 3rd power is 8i to the 3rd times 5i. See if you can finish it from here, though. Just, I didn't want that to mess you up, but see if you can finish 17. Good so far, everyone that sent me it. All right, so a lot of people that you sent me your final answer. Can someone tell me, what did you get when you first multiplied these together, though? Like before you started like simplifying the i's, like what do you get when you just multiply these two like expressions? So as one said, 40i to the 4th power. So 8 times 5 is 40. I to the 3rd times I, you have really 4 i's. Because remember, this is really up to the 1st power. So if you want to think about adding the powers, it's like that. But remember, I to the 4th power, I mean, you could look up here, but I think of it in terms of I squared. So each I, there's 2 I squareds. I squared is -1. So I would change my sign twice. So I would change it to negative, then it would turn back positive. So basically the I to the 4th wouldn't change anything. It would just turn into 40. And those I's would go away. Does that make sense? Because I mean, like if it makes sense, like I'm just, because I write like a child on this, but it's really this. And each one of those I squareds is a -1. So that's why it's 40. If that helps you kind of see it, I would encourage you to try if you can. Oops, flying all over the place. Try and think it through your head, because I mean a lot of times that's like extra right in that usually you want to avoid if you can. I mean, mathematicians are known for being lazy, like at least in terms of writing. That's why like a lot of notation we use is usually shorthand. But that's all I've got for these notes. Don't worry about, we're gonna look more at like questions like these with like roots in them and stuff. I'll put them on like the notes when I post them if you want to look at those, but we'll kind of focus more on these when we look at complex numbers and stuff. I mean, it's no different. You would just multiply, like this would be the square root of 180 this would be, you just multiply the numbers underneath. So what would that be, 72? If I did that right in my head, that would just be negative 144. So it's not anything like too crazy. And then you could simplify it like we saw earlier. But I was more interested in questions like 15 through 17. So on here, let me stop recording though.